Welcome back to week 2 of the Digital Twin Talks by the National Digital Twin Programme. I'm Simon Evans from Arup and I'm facilitating this series of talks on digital twin concepts given by experts from across industry, with these talks hosted here on the Digital Twin Hub. So last week we heard from Olivier Theroux, Head of R&D at the Open Data Institute. Olivier shared the ODI's research and perspectives on moving towards a web of digital twins. It was an excellent talk. They explored what it means to create a web of digital twins, why it's important to have real-world use cases, particularly when prototyping, and how we can make the data infrastructure for infrastructure data. There was also some fantastic discussion and challenging questions both during and after the session on the Digital Twin Hub. So thank you for everybody who got involved in the conversation. This week we have Dr. Brian Matthews from the Science and Technology Facilities Council, where he leads the DAPHNE project team. DAPHNE, or the Data and Analytics Facility for National Infrastructure, is a computing platform to inform infrastructure decision making at a national level. It bridges the gap between academic research, data analysis and strategic infrastructure planning, which is a significant nexus given the data is now considered as important to UK infrastructure as concrete or steel. So over the next 20 minutes, Dr. Brian will be introducing DAPHNE, explaining some of the technical challenges of creating an ecosystem of connected digital twins, and how DAPHNE as a platform can support the national digital twin. He'll also be sharing some real-life examples of both predictive and reactive digital twins. So enjoy the talk, take part in the conversation on the Digital Twin Hub, and share your views using the hashtag Digital Twin Talks.
Hello, I'm Brian Matthews from STFC. I lead the DAPHNE project team at STFC, and I'd like to speak to you today about how DAPHNE can contribute to the Digital Twin Challenge. For context, Sir John Armott, Chair of the National Infrastructure Commission, spoke at our launch event last summer and said data is now as important to UK infrastructure as concrete or steel. The NIC has elaborated on this in its Data of the Public Good report, where it, amongst other things, called for a national digital twin which would bring together individual infrastructure models capturing data on a national infrastructure and the interdependencies between infrastructure systems, thus supporting the development within the infrastructure sector of a data-driven economy. A real grand challenge. So let's see how that would actually come about in practice. So let's start with saying, what is a national digital twin? So starting with the digital twin, a digital twin is a computer model representing a physical asset or system which simulates the operation of its physical twin based on data that comes from that physical twin to predict outcomes, and those outcomes can be then used to set decision parameters which can be fed back into the physical twin to control that digital twin into the future. And twins can typically be of two sorts: reactive twins, where you have a dynamic model of the asset which takes real-time input of performance data as that asset, that physical twin operates via sensors, and then feeds them into the digital twin to predict some outcomes, and then in real time feedback to control the performance of the physical twin. But we also have predictive twins. These are static twins, which are where the physical and digital twin are decoupled. We take some observational data from past performance of the physical twin into the digital model. We run the model or the simulation of the digital twin to see how it might perform in the future, and then based on the results of that simulation, make some decisions about how you would then modify or change that physical twin in the future through capital investment or through changes of its configuration, etc. Now, why are these interesting? Well, all kinds of reasons. Now, predictive asset maintenance, supporting planning decisions, developing resilience, optimizing performance, looking at preemptive action, all sorts of things. So when it comes to a national digital twin, this is a national scale digital twin. Well, a single digital twin would not seem to be feasible. It would just be too large. So we're looking at an ecosystem of digital twins connected together via secure shared data. So this is what CDBB and the Gemini principles has advocated. So if we're looking at a federation of different twins operating by different organisations and coordinated together. And we need to do that an information management framework a common way of understanding information and data, so we can share the outputs and link the outputs of those digital twins into one common view. And the CDB have done a lot of thought around this, particularly developing the Gemini principles as a guide to how we might do a national digital twin. So this gives us a lot of challenges. There are a lot of organisational, social, technical challenges, but I'll highlight three what I consider to be technical challenges of a national digital twin. Firstly, scaling up. We're getting more data, high resolution, more complex systems, more complex models. This requires ever more computing resources, more powerful computing resources, larger data stores, and cleverer use of those compute resources. So that's a real challenge. We need to find those resources. More specifically to digital twins, we have a big data and integration challenge, an exchange challenge. We have to be able to share data between twins in a way that's has common understanding and common preparation, but also respects the needs of security, or needs of licensing of that data. So we need common standards for interchange and common protocols for interchange and appropriation of data, and also a common metadata framework, so we can understand what the data means, we can find it, we can reuse it effectively. And finally, there's an integration problem between twins. Twins in such a national system, ecosystem, are going to be naturally interdependent. One twin is going to depend on the output, one twin is going to depend on the input to another. So we want to be able to integrate them together, and this becomes really magnified when we look at integrating across scales. We need to be able to integrate twins from individual items of equipment right through to the whole country. And we also need to integrate this across sectors. We need to integrate the infrastructure sectors like water, energy, land use, digital infrastructure, transport, but also related areas like environmental data, natural environment, and the economic and social context in which the twin runs. So a very large, complicated integration problem. Okay, so let's move on to DAPHNE. What is DAPHNE? Let's give a short introduction to DAPHNE. Well, DAPHNE is the data and analytics facility for national infrastructure, and it's a new computing platform to support research into national infrastructure. We have 12 university partners led by the University of Oxford, plus STFC, myself at Rutherford Appleton Laboratory near Didcot, which is the host. We're providing the host of the system and doing the development. And this represents an £8 million investment over 4 years, 2017 to 2021, next year, under the BEIS and EPSRC's UCRIC programme, and it's going to provide a next generation platform to support research in infrastructure in the UK. Look at some of the components of it. Well, there is a hardware component underneath, a high throughput computing platform, cluster and platform, with quite significant data store together with some fast data storage. And this will give us some of that scalability we need. And on top of that, we have the actual software components themselves. So a data repository to give us access to data, a national infrastructure modelling service, which allows us to upload and execute models, and also provide a model repository so people can find and access models. We also have visualization suite, so we can visualize the models, a cloud environment for remote access, and it is all within the context of a common security service to control the access to this, to give us the trust we require for a real national infrastructure modelling. To look at that's the components, what functionality they support, where they support obviously login, registration of users, to give us access to that trust framework, so we control access to data and models that people are really allowed to access. We have a mechanism to allow people to upload data, browse data, explore and interrogate data, and it's in the context of a data catalogue where they can browse across data and stored in different systems. Similarly, there's one for models, so people can upload, run their own models, and also form part of a model repository, again within the trust trust framework. We can link those models together to form workflows so they can be chained together, and also provide added visualization on top of those models. So quite a powerful set of functionality to support the development of new models for national infrastructure. So that's a brief introduction to DAPHNE. How is it going to work as a platform to support a national digital twin? Well, we see it contributing in three main areas. Firstly, a hybrid high performance computing platform. So gives us that extra compute and data capacity to allow us to scale up. So we can handle the much larger data sets. We can handle the combinations of data sets that come from different sectors. We can provide higher resolution for models. We can run them more than one model at once. We can provide access to lots of different users at once. And be able to run those models faster than you might be able to do on a typical laptop or in your lab. Secondly, we can provide a secure repository for heterogeneous natural data infrastructure and models. I'll talk a little bit more about that later. And finally, a collaborative platform for research and for the development of digital twins infrastructure assets. I won't talk much about the computing platform anymore. I will focus on what we mean by the secure repositories. So then DAPHNE offers a major component towards the information infrastructure of the national digital twin by providing a data hub. So a place where we can share, integrate, curate data in a common space. So the NID in DAPHNE provides a trusted, secure space to hold and access data. So it makes data, it stores data, makes it available, but also puts that trusted framework around it of controlling who can access it, and for what purpose. We can import data from and also link from different data sources. So, for example, we can take data from the sectors, the infrastructure sectors like energy or transport, but also link through to social and economic data, environmental data. And this gives us a common platform for integration and combining data. So within that, we see that information infrastructure, we see the most important components of that is the rich metadata framework that DAPHNE provides. So we have quite a detailed metadata framework for representing data sets and also different data from different sources. So tabular data about software, things about sensor networks or geospatial data. This is an extensible framework, so we can extend it to the data standards that are supported for water, for energy, for transport. Very much emphasis on data standards here. And this is all makes us a browsable, searchable thing, repository of data which we can then provide and then integrate data together. We have the data store, so we can store a lot of this data, but also we don't need to do that. We can link to data elsewhere. We store the metadata, make it searchable and accessible from elsewhere, and then pull it into the common system. And here we're all guided by the FAIR principles: findable, accessible, interoperable, reusable, which have become ways of providing data, research data, which is both open as possible, so many people can use and reuse it and understand it as possible, but also as secure as necessary, so we can restrict use to the right people. And then moving on to the modeling framework, the NIMS allows the users to upload models from anywhere, but models are containerized using Docker, a system for building software packages. And this allows us to be independent of the original code, the original source, original operating system. So in theory, we can take models from anywhere, any writer, just have to be configured into our system as a Docker container. And then we can run them on our HTC cluster. We use a system called Kubernetes to orchestrate those containers. We can scale up those models to give them more resources, more compute time, to make them faster, to make them larger, more high resolution. And they access the data in the NID and access also the visualization tools within our common framework. And then we're building this, as I mentioned, a repository of models. We're using a system called Harbor to build a repository of Docker containers. So we have an example of there on the right there. So we can provide people a mechanism to browse and share models. but within the same security framework. So here we're providing that ecosystem of digital twins. So a little bit further on that, having got all those models into the common system, we can then build workflows to make those models work together, both chain them together, but also coupling. So if two physical systems are interdependent in some ways, so the outputs of one depend on the inputs of the other, we need to represent that in the digital world. So we want to be able to couple those things, so we can connect the inputs and outputs from the two different digital twins and make them work together in some coupled way, to build sort of common a joint twin, if you like. And this is, I think, is a key feature for our national digital twin ecosystem. So we can couple sector together. So we can try to do that, address that challenge of coupling sectors, coupling models at different scales. Finally, some examples of the use of DAPHNE. So here's a couple. So on the left we have an example which we've been looking at. We've mostly been working in predictive twins. So here a model of a station demand model from the University of Southampton, where we have a choice of a placement of a new railway station, and we look at its effect on where passengers come from, how it affects neighbouring stations, and doing the modelling so we can best optimise where we place a new station. The one on the right, the SIM model from the University of Leeds, is looking at where you make changes in infrastructure and the effect it has on households, jobs, and general economic activity. So this diagram shows an example of that in the Oxford-Cambridge corridor. So one thing that would be really nice to do in our system in the future is to link couple these together, so we can look to see where we can decide where there's a new railway station and have a look at where it affects the economic activity. That'd be a very exciting thing to do. Reactive twins, we've done less work on reactive twins. However, we have started working with the urban observatories in UCRIC. So these are observatories which put sensors around a city or district. So here we have a comparison of the Sheffield and Newcastle urban observatories, looking at traffic movement from morning's traffic flows, seeing where traffic is building up. So we can compare the data from different places at once, and that gives a kind of example of the advantages of a common platform for combining data from two different urban observatories. This is kind of early work. We still think need a lot of rather more thinking and work around how we support reactive twins more generally in DAPHNE, particularly around how to handle sensor data, how do we handle data streaming, and how we build an architecture, a fog to cloud architecture, whether we put compute close to the sensor in the urban observatory or where we need to put data in a central place. So to summarise what we are proposing in DAPHNE, we see DAPHNE as an environment for doing research and collaboration in developing the National Digital Twin, and a place where researchers, government, industry can come together to explore new ideas in modelling and twin development. So our interruptible approach will give us a cornerstone for that ecosystem. So HTC platform, so we can scale up models, but also within this common information infrastructure to allow us to do data sharing within a secure, trusted environment. And then we can scale up a model, a couple models together to do some of those grand challenges I mentioned, technical challenges I mentioned. So, and all the time respecting the Gemini principles of digital twins. So, in this way, we can then build a digital twin, or national digital twin, to support the sustainable development of infrastructure for our country into the future. Okay, thank you for that. Thank you for listening.